Hey everybody, day 2 of notes here. We're going to get started pretty quickly. Hopefully the first day went well for you, but shouldn't be too long. So today we are going to look at simplifying expressions and notes, and then there is an exit ticket at the end. So again, anytime you're going through notes, if something's not making sense, like in the video that I have, the reason why we did the iBook yesterday is so that you can go in there and look. So for instance, the first question or example that we have here is talking about like terms. Okay, well, if I don't know what a like term is, obviously you can look at these notes, but I'm getting this definition straight out of the iBook, okay? So what are like terms? If you go to combine like terms are terms in an expression or equation that can be combined. Okay, now, that definition is kind of weird, right? Because it says combine like terms. What are like terms? And it kind of uses those same exact words in the definition as to what the actual word is. So the easiest way to think about this is looking at examples. An example of a like term is something very basic, something you learned in elementary. What is 2 plus 4? Okay, 2 plus 4 is equal to 6. So you can combine those, right? This is an equation, but you could do it with an expression too and just say that it's 6 and not have to use the equal sign. Okay, those are like terms. Those are things that are of similar, I don't even know what the word is, but they're similar, and so you can combine them. So let's think about another one. How about x plus x? X plus x, well, how many are there? There are 2 of them, so that would give you 2x. Okay, let's get a little more complicated. How about 3x plus 12x? Okay, well, now you're combining the like terms. They are like terms because they both have an x, so you're just combining the coefficient. Okay, 3 plus 12 is 15, so there are 15 x's. Okay, so that's what like terms are. Now, what are some examples of non-like terms? Well, if I were to say, what's 2x plus, or actually better yet, what is 2 plus x? Well, they don't combine because one is a number and one is a letter, right? So you cannot combine those, right? How about 2x plus 3y? Okay, so in this case, we have a coefficient and a variable, so they seem to be like terms, but as you can see, one has an x, one has a y. So these are not like terms. All right, here's one that's even more complicated. 2x squared plus 3x. Okay, they both have a coefficient. They both have an x, but notice the difference. This one has an exponent of 2. This one has an imaginary exponent of 1. So these are not like terms. You cannot combine those. Okay, but sometimes you'll have it where it's like 2x squared plus 4x plus maybe 3x squared. Okay, so now what you can do is combine the ones that are similar. The coefficients can be different, but they both have an x, and they both have the same exponent. So 2x squared plus 3x squared is 5x squared, and then 4x is by itself. Okay, so that's an example of like and non-like terms. So let's go through these examples here. Simplify the following. You can, if you're on paper, you can just underline those that are alike, or with 1 or 2 marks to separate the differences. Or I know I personally like the fact that with Notability you can highlight, okay, and say what the like terms are. Either way, 4x plus 5x is 9x, and then this is a negative 2x, so 9 minus 2 gives me 7. This is 7x, and then negative 2 and a positive 7 gives me a positive 5. There's our solution for that one. Okay, next one. 10x, positive 2x, negative 4y, negative 2y. And then this one is x squared, and there are no other x squared, so it's by itself. Now what you should always do is put them in order from highest exponent first. Highest exponent first. 3x squared has the highest exponent, so it's going to go first. I'm done. I can cross that one off. Okay, 10x and 2x gives me 12x. Okay, so 10x and 2x. And then negative 4y, negative 2y. 2 negatives remain negative. It gives me a negative 6y. Done. Okay? All right, so now what about distributive property? Well, what math operation does distributive property use? We should all know this. Multiplication. It should be a review. Okay, so what we're going to do is use that distributive property in multiplication to combine like terms. So in example 1, okay, distributive property is where you have a number or something outside of the parentheses, right? And what you're going to do is distribute it to both terms that are inside the parentheses. So 3 to x and 3 to negative 4. And when I distribute, again, I'm using multiplication property, so this becomes 3x minus 12 because negative 4 times 3 is negative 12. Okay, same thing here. Negative 4 distributes to both the x and the 3, so it becomes negative 4x. And negative 4 times a positive 3 is negative 12. Most common mistake is that students will forget to do the second distribution. Always remember to distribute it to all the terms. Okay, now once we're at this point, we can combine like terms to simplify it down even further. So 3x minus 4x is a negative 1x, and negative 12 minus 12 is negative 24. Done. Okay, example 2, same idea. Distribute the 2 to both terms, distribute the negative 5 to both terms, 2x minus 10, negative 5x, plus 20y, because a negative times a negative is a positive. Okay, combine like terms, x's, this one's got a y, this one's just a constant. Okay, so 2x minus 5x is negative 3x, plus 20y, because there's nothing else that has similar, minus 10. Done. Notice the constant always goes at the end, right? Constant's at the end. Okay, so here's what I want you to do. Go ahead and start the examples, and we're going to go through those together. If you have any questions, obviously I'll be here in the Zoom meeting, and then I want you to finish this exit ticket for practice tonight. This will be graded. So, see you in class.